Right, to hyperbolas. You have two different hyperbolas. They can either open out, or opens horizontally, or they can open vertically, up and down. Okay. Now, how do we know which way they're opening? Well, if you look at this equation, do you see how the x squared minus y squared, where here it's y squared minus x squared? So it's basically whichever one letters first. If the x squared's first, it's going to open left or right x axis y's. If the y squared's first, it's going to go open up and down the y axis y's. Now also the reason for it is a squared is the first denominator. See how a squared, and with ellipses, a squared is where it's stretched. Same thing here. A squared is basically always going to be the first denominator. It doesn't matter if it's bigger or smaller, it's always the first, which means that the first letter tells you which way it opens. And there's always a minus, by the way. On a hyperbola, there's always a minus. That's one big difference between an ellipse and a hyperbola. The only difference, really, is that there's a minus instead of a plus. So, when you have an equation like this, for instance, this right here is graphed right there. Now, how does this make this? Well, what happens is, first of all, you take the a value. Just like before, to find the a, it's a is going to be equal to plus or minus the square root of 4. So what you get is a equals plus or minus 2. So you have plus or minus 2 comma 0. That's your vertex. Plus or minus 2 comma 0. Those are your vertices. Now there's no co-vertices here, but you still need to find B. There's a reason for finding B, because to find B is going to be plus or minus the square root of the 9. See the B, the second value, which is plus or minus 3. Now you don't need that for your graph. It's not one of the coordinates, but you need this because what's going to happen is you're going to go up 3 here and down 3. And what you do is you create a box. It's kind of different. You'll see why in a second. What we're doing here is we're making this little box here. That's the B value. You make a box. Before there was an ellipse that fit inside of this box. Now it's a hyperbola. But what you're doing is, from this box, you are creating an asymptote that goes through the corner of this box. Through the center and through the corners of the box, this is creating an asymptote. An asymptote is a line that we approach but never touch. So what happens is, you notice this hyperbola gets really, really close to this asymptote but never touches it. So this asymptote idea helps create these lines. Now, right here they're asking for the asymptote. So what's the equation of this dotted line right here? Well, isn't it at 0, and the slope is up 3 over 2? So up 3, isn't B 3? And isn't A 2? So isn't there an asymptote, and isn't there a negative one as well? Isn't this down 3 over 2, up 3 over 2? So aren't there two asymptotes? There's a positive and negative one. The slope is, in this situation, B over A. 3 over 2x. So when you look at this, what's the slope of that line? It's up 3 over 2, down 3 over 2. Those are my two asymptotes. Now, one way to remember this is it's always going to be the y value, which in this situation is b, over the x value. And that's your asymptote. Lastly, to find your foci, it's a little bit different than the ellipse. For the foci of this, you need to do c squared is equal to a squared, which is 4, plus b squared. Then from there, what we're going to do is we're going to solve this. So that looks like it equals 13. So to find the foci, what you have now is you have c squared is equal to 13. And when you square root this, you get c is going to be approximately, with 13, somewhere between 16 and 9, closer to 16 than 9, but kind of right in the middle. So it's probably going to be somewhere about 3.6. So I would still leave it for the answer. I would leave it as plus or minus the square root of 13, comma 0, which is about 3.6, which means there's going to be a focus that goes about 3.6 this way and 3.6 this way. Those are my focal points. Okay. And you have to do it by adding a squared and b squared, square rooting it, and that tells you how far away. Now, the focal points will always be inside of the different hyperbolas. So, let's do another one. This one is opening up or down. So the vertices are going to be up or down. That's why the a value is in the y value, because we can go up and down. Now how do you find the a value? With the first denominator. So a is going to be plus or minus the square root of 9, which is plus or minus 3. So what's going to happen here is 0, comma, plus or minus 3. So as you can tell, aren't those 2 points up and down 3? Those are the vertices. You go up 3 and down 3. Next, to find the asymptotes, what we first need to do is find b. So b is going to equal to plus or minus the square root of 49, which is positive negative 7, which that means we're going to go over 7 in both directions. And then remember, we make this box because this box helps us create our asymptotes. And you have these asymptotes that go like this. Again, an asymptote is a line. Oops, I messed that one up. Asymptotes are lines that this hyperbola is getting closer and closer to, but never touching. They kind of give you boundaries. Now, from there, I want to find the equations of my asymptotes. So look at this line. The right, it's 3 over 7. So the graph is positive or negative because there's one down 2. One's down 3 over 7. It's going to be 3 over 7x. So we look at this line again, and the slope is, the box actually gives us a slope, up 3 over 7. So up 3 over 7, that's the equation of the line. Now, why isn't there a plus 0? Well, you could, because right here in the middle is 0. So really there's a plus 0 here, but we don't usually put it because it's just, this is the equation of the line, y equals up 3 over 7, starting at 0. And so that's simply the axis, that is the asymptote, the equation for both asymptotes. One has a positive slope, one has a negative slope. Now, what's so special about the asymptotes again? They help you create the graph. You'll see later when you actually have to graph one on your own. And again, for this, if you see this, the 3 comes from the y, the 7 comes from the x. And as you can see, slope 3 over 7, the y over the x. Rise over run is slope. Slope is rise over run. And then again, if you look up here to find c, it's a squared plus b squared. So c squared is going to be a squared, which is 9, plus b squared. So that looks like we got a 58. And then from there, it looks like we're going to have c squared equals 58. And when we square root that, you get c is equal to positive and negative square root 58, which is approximately, well, between, let's see, that's between 7 and 8, closer to 8. So I would probably say 7.7 maybe. Anyways, that would be your value, but basically 0, comma, plus or minus square root of 58. That is your foci, this value, but that's the reason I want this decimal, because what's going to happen in this foci, if you think of this, that foci is going to go all the way down here to 7 point something, and all the way up here to 7 point something. There's your foci. These two dots are your foci. Alright, so again, you need the decimal a lot of times to get the value, otherwise you don't know where it is, but you can write it as a foci, usually as a square root. And as you can tell, the c value went in the y value because we're going up and down. See how the graph goes up and down? So won't the c value go as a y? Where here, see how the c value was an x because it went left to right inside of the hyperbolas? Okay. Again, hyperbolas have a minus, ellipses have a plus between. And the first denominator is your a value, not your largest.